A few months ago, we built this. This is the Atlas version 1. It's an 8-foot diameter sphere, modeled after the giant LED sphere in Las Vegas. We hadn't even finished the Atlas version 1 before we started thinking about ways to make it better. Now, here we are with our second version. We had two main goals. First item on the list was to increase the resolution by putting the LEDs closer together. And the second was to make it possible for just about anybody to build it. Good news, we achieved both. You want to see how we did it? Let's dive in. The Atlas version 1 has these bullet-shaped pixels that are 1 inch apart, both vertically and horizontally. There isn't any practical way to get these pixels any closer together. The strapping is 1 inch in width, and the spacing between the pixels is 1 inch. Plus, on the smaller circles, it got pretty tight in there. So even if we could get smaller strapping, it really wouldn't work. So the first change we made was to go with LED strips instead of pixel strings. We chose strips that are 1 centimeter wide with LEDs that are 1 centimeter apart. That way we could keep the horizontal and vertical distance between LEDs the same. We chose IP65 strips with the hope that this version of the sphere could at least be a little bit protected. It isn't waterproof like the V1, but it's better than bare LED strips. As we already said, the V1 has 1 pixel every inch vertically and horizontally. That means the resolution is 1 pixel per inch. The V2 has LEDs 1 centimeter apart in both directions. 1 square inch is about 6 square centimeters. So the V2 has a resolution of about 6 pixels per inch. It doesn't sound great, but that is a 6 times increase in the resolution. Compare that increase to the difference between an HD TV and a 4K TV. 4K TV has 4 times the pixel density of an HD TV. Our new sphere is 6 times the pixel density of our old sphere. That's a pretty good step forward.
Talking about resolution is only really meaningful when you consider viewing distance. The Las Vegas sphere has 1 LED per square foot. Up close, it's not really a screen, but from far away, it looks amazing. We can pinpoint the optimal viewing distance for the new sphere since there are equations for this sort of thing. After crunching the numbers, the optimal viewing distance is around 80 feet. While numbers and equations provide valuable insights, practical testing is a must. I'll showcase the same recording at 5 different distances: 10 feet, 20 feet, 40 feet, 80 feet, and 100 feet. I wish you could see this firsthand. The experience surpasses what the camera can really capture.
The V1 frame was made out of plywood that was cut on a massive CNC router. Not many people have a massive CNC router, but a lot of DIYers do have 3D printers. So DrZzs designed the frame of the V2 to be 3D printable. It's pretty ingenious how it all goes together. Everything can be snapped together to make 2 halves, and both those halves are held together with a long threaded rod that supports all the weight. When you're ready to make your own, we've made the files available to our Patreon supporters. The link to our Patreon website is in the description below. Big thanks to our current Patreon supporters. Thank you for your support. Designing and building a sophisticated design like this involves a substantial amount of trial and error. Thankfully, we had the Bambu X1 Carbon on our side. To demonstrate its efficiency compared to hobby-grade printers, we sliced the largest ring for the Atlas V2, which typically takes around 5 hours to print on a typical hobby printer. The Bambu X1 Carbon, on the other hand, pulled it off in just 1.25 hours. This time-saving aspect significantly aligns with the fail-fast mentality of experimenting and swiftly determining if our ideas will pan out. This is where the magic of 3D printers, especially the Bambu X1 Carbon, truly shines, allowing us to iterate at an impressive pace.
Now, the secret behind this efficiency lies in the Bambu X1 Carbon's ability to accelerate the printer head at 20 meters per second squared. That's twice the force of gravity. While owning a Bambu X1 Carbon isn't a prerequisite for building the Atlas V2, having one certainly makes the entire process a whole lot smoother. If you are interested in getting a Bambu X1 Carbon or one of their other amazing printers, use our affiliate link in the description below. Okay, now back to the sphere. The sphere is composed of just a few different parts. It is made up of 8 vertical supports and 49 rings, and each ring is made up of 8 different sections. All in all, there are just over 400 different 3D printed parts. I was really excited to see the sphere put together, and sometimes when I get excited, I don't think things all the way through. That is why it is a good idea to have a plan in place. A plan that should have been in place before I even started assembling.
One of the things that me and DrZzs do best is that we screw up so you don't have to. That way, we can show you how to avoid the same pitfalls. We were so excited to get the frame built that we didn't really think about how exactly we would be connecting all the LEDs.
The problem with putting the sphere all together was that it made it really difficult to access the soldering connections. I was constantly flipping the hemisphere back and forth. You need to access the outside so you can wrap the lights, but then you need to access the inside so you can wire each of the rings together. Constantly flipping it back and forth is just a waste of time. So we suggest building the circles first, then putting the LEDs on the rings, drilling the holes, soldering the wires, then attach the ring to the frame. We all know that the 3D prints are only so strong. Yes, you can make them pretty strong, but if it's going to be under a constant force, then you want to have something structural to hold the load. So the entire sphere is actually hanging off this threaded rod. The power supply has a very stout 3D printed bracket to attach it to the threaded rod. This is the heaviest part of the entire build, and we need to make sure that it isn't going to go anywhere. The controller is a Culp 16 board. We used a similar board on the V1 and it works like a champ, so we just got the size down for the V2. It's important to make sure that all of the LED strips are wrapped in the same direction, because if they don't, the animations just won't work. When wiring this up to the Culp controller, the general rule of thumb is not to put more than 800 lights on a single channel. And after a number of days of toiling away, we finally arrive at this exceptional piece of work. But wait, hold your applause, because we're not done yet. To conquer this LED beast, we must design a model that can magically transform the images and videos we want to see into a symphony of timings and colors for each pixel. Easy, right? Just another stroll in Tech Wonderland.
It's time to talk about how we actually make this thing display videos and effects. I'm going to assume that if you're attempting to build an LED sphere, that you have at least some experience. I do believe that anyone can do this, but this should not be your first LED project or your first experience with X-Lights. If you're not here to see the details of the X-Lights setup, skip ahead about 2 minutes to see the demo of the sphere in action. When you have your Culp 16 powered and connected via Ethernet to your network, X-Lights Discovery should find it. This populates some of the necessary information, but not all of it. We still need to select the vendor and the model. Then we can save and go to the Layout tab. We're going to import the model. Click and drag to make a rectangle, and it will open your file manager to select the model file to be imported. This model is one of the most important parts to making this thing super cool. If you look at it up close, it looks like a rectangular matrix, except there are less dots at the top and the bottom than there are in the middle. That's how we can get a flat image or video to wrap around the sphere and not look totally screwed up. This X-Lights model is also available in the downloadable files, but it may need to be modified if your sphere has different numbers of LEDs in the rings. Huge thanks to Pixel Heads, DrZzs, and Alkley for figuring out how to make this model. You guys rock. Number of strings is the number of outputs you're using on the Culp controller. For this sphere, we're using 8. We need to set individual start nodes. Clicking this checkbox lets us do that. By default, it will just divide the total number of pixels by the number of outputs. But that won't work for us. We need to change each of these based on the actual number of pixels we have connected to each output. I've got a cheat sheet I'm copying from. If you actually build one of these, you'll likely have to change these numbers based on exactly how you built your sphere, but that's a problem for future us to worry about. Finally, we select the controller, and port 1 is our starting port. Now save, and then go back to the controller tab and upload output. The magic in X-Lights happens in the sequencer tab. Now, start a new sequence. If you want audio output, select musical sequence. Then select the audio or video file you want for the audio. Drag the video effect onto the model on the timeline. Stretch it out to match the duration of the audio file. Use the Browse button to find the video you want to display. You can see in the preview that the top of my video is being cut off. To fix that, I'll drag the yellow box down until it looks like I'm getting the whole image. Important tip, there are a lot of 5-volt LEDs on each of these outputs. If you don't turn down the brightness, you'll be popping fuses. Don't ask me how I know. Now render by clicking the palette button and then save. To upload the sequence, we use Tools, FPP Connect, then select the controller, and then select the sequence you want to upload. Now it will appear in the list on the controller user interface. I know that was complicated and I covered it really fast, but I'm sure it was too much detail for some and not enough detail for others. But that's why we have Patreon and Discord. Now that's enough yapping. It's time to show what the Atlas V2 can do. It's demo time. As always, thanks for watching.
Until next time, adios!